Hello and welcome to our second lesson on quadratic functions. This time it's our vertical shift or vertical translation lesson. And we start out with the graph we did last time first, which is y equals x squared. And I've already done this for us because it's just a bit of a recap. So here we go. You should remember that that's what the graph looked like. There's our vertex 0, 0. Axis of symmetry is our mirror line down the middle, x equals 0. We're opening up. Our domain is any x, or x is real. And our range is y is greater than or equal to 0. Alright, so question 2, we've got something new. We've got y equals x squared plus 3. So you remember in the first lesson we had numbers in front of the x squared times x squared. Now we've got y equals x squared plus 3. So let's use our normal numbers here, negative 2, negative 1, 0, 1, 2. If I put in negative 2 for x, I get negative 2 squared is 4. So the right side is going to equal 7. So if I put in 7 for y, that's going to make that equation true. Alright, I put in negative 1 squared is 1, plus 3 is 4, 0 squared is 0, plus 3 is 3. And let's throw these on the graph. There we go. Okay, so we've got a new vertex. Vertex is 0, 3. Axis of symmetry, still straight down the y-axis at x equals 0. Opening up. Domain, x is real. And this time, y is going to be from 3 and up. So y is going to be greater than or equal to 3. Alright, so what's the difference between these two graphs? Well, it's the exact same shape, it's just been moved up 3 units. So we have a vertical translation, or shift, up 3 units, or just up 3. Okay, and if we think about taking our picture on the computer, we're basically just grabbing it with that arrow thing and just moving it up 3. Doesn't change the shape of the face at all. It's the exact same face, it's just up 3. Okay, I'd like you to have a look now at question 3 and try that yourself. And I'm going to pause and fill out the answer for you, and you can check it. Alright, so there's the graph of y equals negative x squared minus 2. Notice the negative in front of the x squared has us open down, and the minus 2 gives us a vertical translation of 2 down. Okay, and again now for question 5, I'd like you to make some predictions. There's 3 things I'd like you to think about. Think about which way they're going to open. Think about the vertex. And think about the shape. And by shape I mean, will it be vertically expanded or compressed? Okay, so take a second to make some predictions, and I will pause and be back in 2 seconds to give you the answers. Alright, here are the answers. So our first one, because of the negative here, we're going to be opening down. Our vertex is still going to be at 0, 0 because we didn't add anything over here. And our shape is going to be the same shape even though opening down, because it's as if there's a little invisible 1 here, so it's a negative 1 x squared. Okay, our second one will be opening up because we have a positive 2 in front of the x squared. Our vertex will still be 0, 0 because we don't have anything over here to vertically translate it. And our shape will be expanded by a factor of 2. So it's going to look longer and skinnier because we've expanded it vertically. Alright, number 3. We're going to be opening down because we have a negative in front of the x squared. Vertex is still 0, 0 because there's nothing over here. And this time we're going to be compressed vertically by a factor of a quarter. Okay, fourth question. So opening is going to be up because it's like there's an invisible positive 1 here. Our vertex is going to be up at 0, 5 because we'll have a vertical translation of 5 up. And our shape will be the same as usual because we have the 1 there. Last one. Again, we've got the invisible 1 here. So that will mean we're opening up and have the same shape. And our vertex will be 0, negative 7 because we have a vertical translation of down 7. Okay, for number 6, let's make a prediction. We need the same 3 things. So the first thing we should notice is that negative. So we know we're going to open down. Next is our vertex. We're going to be translated up 5. So our vertex is going to be 0, 5. That is a 5. And then our shape, we've got the half here. So we're going to be vertically compressed by a factor of a half. So it's going to look a little fatter because it's been squished up and down. Okay, and we've got y equals negative 1/2 x squared plus 5. And let's start at negative 4 this time because we have room. And if I put negative 4 into this equation, BEDMAS says I go negative 4 squared first. So that'll give me 16. 16 times negative 1/2 will be negative 8 plus 5. So if I put in negative 3 for y, that'll make the equation true. And there's the rest of the values quickly to save time. So there's our vertex at 0, 5, like we knew was going to be there. Oops, and I messed up somewhere. There we go. So there's our parabola, and while I'm over here, I might as well draw on my axis of symmetry. Notice the axis of symmetry is just a mirror line, it's not part of the solution. Alright, and our vertex, as we said, is 0, 5. Our mirror line, our axis of symmetry, is at x equals 0. Opening down, because we had a negative in front of the x squared. Domain can be anything, so x is real. And our y's are going to be from 5 down, so y will be less than or equal to 5 for our range. Okay, down on number 8 now, talks about maximums and minimums. Okay, so if you have the top of a hill, you're going to have a maximum. If your graph looks like this, then you'll have the bottom of a valley. That'll be a minimum. So we can see that in this case, we have a maximum. You should always write your maximum like this. So we say there is a maximum, you can write max if you like, of y equals 5 at x equals 0. So you can think of it as you're kind of driving along this parabola here, and oh, we're at altitude 1, we're at altitude 3, 4, 5. Oh, there, here we are, we're at the top of the hill. Maximum altitude. When did it happen? when x was 0. Thinking about it this way is going to help us when we get into the word problems. So I'd like you to write it like this, think about it like this, so that when we get to the word problems, things will make a lot more sense. Alright, question 9 wants the equation for a parabola with vertex 0, negative 1. Alright, so there's our vertex 0, negative 1, and it passes through negative 3, negative 19, so it's going to be somewhere down here. Just roughly. And if the vertex is here, then the axis of symmetry is also going to be there. So we'll also have a point. Oops, that is 319. Sorry. There's our negative 3, negative 19 over there. My fault. And we'll also have a point on the other side of the axis of symmetry at 3, negative 19. So our parabola is going to look like this. So again, here's our point. They gave us negative 3, negative 19, and then we also have one on the other side of the mirror at positive 3, negative 19. Okay? Notice that we've been shifted down 1 unit. So our equation will have the form y equals something, x squared. I don't know what that something is. But then minus 1. The minus 1 is going to translate us down 1 unit. Okay, and then we can use our point negative 3, negative 19 to figure out what a is. Bed mass, I should do negative 3 first. That'll give me 9. So I have negative 19 equals 9 times a minus 1. Add 1 to both sides. Negative 18 equals 9a. And divided by 9, a is going to equal negative 2. Notice that it makes sense that a is negative because we are opening down. So our equation will be y equals negative 2 x squared minus 1 for that parabola. Alright, and now question 10. So we need the equation for a parabola with axis of symmetry, x equals 0, and passes through those 2 points. So our axis of symmetry is going to be right down the middle here. And it's going to go through the point 1, 2. And it's also going to go through the point negative 2, negative 7. And because of the axis of symmetry, we also know we have a point at negative 1, 2, and a point at 2, negative 7, which means our parabola is going to look like that. Okay, and they've also given us a hint, because all our parabolas today have been of the form y equals ax squared plus q, because they've all had an axis of symmetry at x equals 0. So let's take our first point 1, 2 and put it into that equation. So we get 2 equals a 1 squared plus q. And we have our second point. And let's just simplify those. So that's going to give me 2 equals a plus q, and negative 7 equals 4a plus q. And that gives us a system of linear equations, which you guys did last year. And there were 3 ways to solve that: graphing, substitution, or elimination. I am going to do, let's do substitution for the heck of it. So from the top equation here, actually let's work with the bottom equation because it's easier to get at. Let's subtract 4a from both sides. Oops, that's a 4, not a 9. So we'll get negative 7 minus 4a equals q. And now we can replace this q up here with negative 7 minus 4a. So that's going to give us 2, oops, equals a plus negative 7 minus 4a. Or 2 equals negative 3a minus 7. Add 7 to both sides. We get 9 equals negative 3a. We get a equals negative 3. And now we can use this equation to figure out what q is. So we get negative 7 minus 4 times negative 3 equals q. Ooh, that is not a q. Which gives us q equals, is that 5? Yeah. Perfect. So our equation is y equals negative 3 x squared plus 5. Which would mean that our vertex would be 0, 5, which makes sense. And we're opening down because of the negative, so that makes sense. And we're vertically expanded by a factor of 3, which also makes sense because this parabola is quite spread out vertically.